Hi, we're going to talk about summation notation, also known as sigma notation. When we're trying to add terms of a sequence, we use summation notation or sigma notation. This letter here, this is a Greek letter sigma, which actually represents letter S, equivalent of letter S in our regular alphabet, and that represents summation. So let's identify the parts. This is the sequence that we're going to be working with. That's going to change. We have this number on the bottom. This is what we call our lower limit of summation. Then we're going to have a number here when we're actually going to see a problem. As you can see in the example below, this is called the upper limit of summation. And there's going to be always a letter here that is going to be called the index of summation. And this is basically how it's going to work. Let's take a look at the first example. So we have this summation. We're going to start at 1. We're going to go all the way to 5. And this is the expression where everything's going to go. So this is how it's going to work. We're going to make I equal 1. And we're going to substitute 1 into this expression. So 2 times 1 minus 3 will give us negative 1. Plus, we're going to make I equals 2. So now we're going to substitute 2 in there. 2 times 2 is 4. 4 minus 3 is 1. Plus, we're going to make I equal 3. When you substitute 3 in there, you're going to get 3. Then we're going to make I equal 4, which is going to give us 5. And we're going to make I equal 5, which is going to give us 7. We do not go above 5 because this is when we reach our upper limit of summation, so we are going to stop there. And all we need to do at this point is just add the numbers together. How do we know we are adding numbers? That's what that letter here is telling you. That letter sigma means we are looking for the sum of the terms of the sequence. Okay? So we're going to do negative 1, plus 1, plus 3, plus 5, plus 7. That is going to give us a total of how much? 15, right? So that is the answer here. Alright? Let's take a look at another example. Example 2. The letter here may be different, so I used a different letter on purpose. So it could be K. You can actually put any letter there that you want. So your index of summation does not have to be I, it could be K. Just like when you solve equations, your variable does not have to be X, it can be another letter. Okay, so what's the process here? We are going to do the same thing. We're going to make K equal 1. Substitute 1 in here. 1 squared is 1 plus 1 gives you 2. Plus, we're going to make K equal 2. And we're going to make K equal 3. And we're going to make K equal 4. We're not going to go beyond that because we have to stop at 4. So when you substitute 2 in here, it's going to give you 4 plus 1. That's 5. When you substitute 3, it's going to give you 9 plus 1, which is 10. Plug in 4. 4 squared is 16 plus 1 is 17. Okay. And we're going to add all these together. 2 plus 5 plus 10 plus 17. That is going to give us 34. Okay. Next example here, you have this kind of expression. So we're going to go from 1 to 6. As we understand, we're going to have to make I everything from 1 through 6. So I equals 1, I equals 2, I equals 3, I equals 4, I equals 5, I equals 6. So when you plug in 1, you're going to get 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. right? I know some of these fractions can be simplified, but I am not going to do it on purpose because it's going to make things easier to add when we have it in this form, right? So 1 plus 2 plus 3 plus 4 plus 5 plus 6, basically what we're adding all over 3. And that is going to give us 21 over 3. And that can be simplified, and the simplified answer here is going to be 7. Okay, I have one more example to show you. So this here, remember that the lower limit of summation, you cannot assume that it's going to be 1. You can have a different number here. In this case, we have 2. Okay, so we're going to start at whatever number we have on the bottom. And we're going to have k equal 2, k equals 3, k equals 4, and k equals 5. That's a little bit of a more challenging expression, so this is going to be, when you plug in 4, it's 8 minus 4, which is 4. When you plug in 3, it's 27 minus 9, which is going to give you 18. 4, it's 64 minus 16, which is 48. And then with 5, it's 125 minus 25, which is 100. So we're going to add all these together. It's going to be 4 plus 18 plus 48 plus 100. And it's going to give us 170. And this is how it's done. I hope this helps.